अच्छा, यहाँ से हमने स्टार्ट किया था कि कंपैरिजन। तो आई टोल्ड यू दिस इज व्हाट बेंजीन looked like. It had three alternating, you could think of it as three alternating double bonds, or what would happen is कि वो जो double bonds थे, the pi electron cloud, it would they would all mix up, or electrons would become delocalized. So you didn't exactly know where the pi bond was, or it was everywhere on all the carbon atoms at the same time. तो उसके the main जो चीज we discussed was that the electron density is lower, कम होती है, ठीक है, it's lower compared to वो जो आपका, अच्छा, compared to your alkene, where the electrons are more concentrated. ठीक है, the pi bond is at a very specific place. So over there, आपका जो pi bond था, that was more localized. तो benzene के the electron density was lesser. तो difference ये था कि alkenes had electrophilic addition, which basically meant कि it had electrophilic addition, which basically meant कि the electron density is so high that it would polarize the bromine molecule very strongly. The electrons are going to be repelled in bromine, and one of the bromines will become very strongly negative. The other one will be very strongly positive. The positive bromine will be very strongly attracted to this high charge density electron cloud. And तो इसलिए वो reaction खुद ही होता था. It would happen at room temperature. You did not need any special conditions for this reaction. And all alkenes, they would undergo electrophilic addition without any help. ठीक है, bromination, hydration, hydrogenation, and your reaction with hydrogen halides. खैर इसको अब बेंजीन में ये था. The thing that we discussed in benzene was that there were three reactions, which were known as electrophilic substitution reactions. One is with bromine, one is with chlorine, and the other one is with nitric acid. एक जगह NO2 attach हो जाता है, one is Cl getting attached, the other one is Br getting attached. All three of them are difficult to happen. They don't happen without a catalyst. You need a catalyst, AlBr3 or FeBr3. Agar chlorine hoga, it's going to be AlCl3 or FeCl3 catalyst. And if it's nitric acid, you want to attach NO2 to it, then it is going to be concentrated sulfuric acid as a catalyst, and the temperature is going to be 55. तो इसका हमने डिस्कस ये किया था कि why do you need a catalyst? I told you that polarization of the bromine does not happen very strongly. The benzene electron cloud is weak, its charge density is lesser, so the polarization is very weak as well. यहाँ पे there's very weak polarization. इसको एक सेकंड में इसका कलर चेंज कर दे रहा. अच्छा, so anyways, the polarization was weak. The electron density was not very high. So the bromine electrons will not get repelled. They're not going to get repelled very strongly. So the negative charge and the positive charge are going to be small in size. So the positive bromine is also not going to be attracted to the electron cloud because it's a very low charge density electron cloud. So what you need is a catalyst. FeBr3 from the other side will attract the bromine. Uske electrons ko it's going to attract it, and that will polarize the bromine molecule further. The positive charge will become stronger, and what this positive bromine will do is it's going to go to this benzene, and वो जो उसका एक p orbital बचा था ना carbon का, it's going to take that electron and bond with it. So the benzene pi electron cloud would become partial or incomplete. And when it becomes partial or incomplete, there's going to be a positive charge on the benzene ring because bromine took its electrons. Well, what happened to the other bromine? It went with its electrons and bonded or datively bonded with this iron over here. Our next step होता है कि the benzene electron cloud needs its electrons back. So the H is the one that gives the electron back, and when it gives the electron back, तो उसका जो electron cloud it becomes complete again. इसको मैं shade भी कर देता हूँ that अच्छा इसको शेड कर देते हैं that the electron cloud, अच्छा this electron cloud over here, um, अच्छा वो कंप्लीट हो जाता है this one. जी मेरे ख्याल से मैंने गलत वाले को कर दिया. ठीक है this one. तो वो H अपना इलेक्ट्रॉन it gives it back and the benzene basically gets its electron back. वो H चला जाता है. Where did the H go? It left its electron and bonded with the Br over here. So HBr is formed and the FeBr3 catalyst. इसके पता नहीं -1 चार्ज नहीं हटाया. ठीक है now. The FeBr3 catalyst is reformed. So that's the whole reaction. ठीक है, that's the whole reaction in front of you. But you need a catalyst for this. Or we drew the mechanism. This is the mechanism that you're going to draw. So that you're going to draw in the exam. ठीक है, तो एग्जाम में मतलब आपने वो ऊपर तो it was just explanation. So this is your exam mechanism. अच्छा और फिर ये था कि which is pretty much the same thing. And you also the other thing is कि अच्छा the other thing is there was nitration of a nitration mechanism as well. So we did this, you take benzene and NO2 gets attached. What happens is that concentrated nitric acid and sulfuric acid, they first end up reacting with each other. So they are the ones that undergo a reaction first. So concentrated nitric acid and sulfuric acid, they react, and that ends up producing a nitronium electrophile, an NO2 plus 1. And this NO2 plus 1 kind of does the same thing. It goes and bonds with the benzene electron cloud. अच्छा वो खुद से react ही करेगा. You have to produce, because remember the benzene electron cloud is very weak. It's got a low charge density, so it can't uh, extract the NO2 plus 1 from the nitric acid. It can't polarize the nitric acid. आपको NO2 plus 1 उसको बना के देना पड़ता है. ठीक है, then the reaction happens. So which is, and that who makes it? The catalyst makes it. The catalyst is specifically added for this purpose. You get NO2 plus 1. NO2 plus 1 does the same, goes and takes away one of the p orbitals in the electron cloud, and the carbon and this whole electron cloud becomes electron deficient. It's got a positive charge. फिर वो आ जाता है H. H loses the electron, gives the electron back. और इस तरह उसको ना the benzene gets its electrons back. और इसको भी शेड कर देते हैं this electron. H is the one that loses those electrons and gives it back. ठीक है, so the H goes and bonds with the HSO4. तो ठीक है, ये सारा mechanism था. This was the mechanism that you're going to draw in your exam. कि NO2 plus 1 आया, the electron cloud become partial. H then gives its electrons. थोड़ा सा सही करके draw कर लेते हैं. ये वाला part एक second. अच्छा ये electrons को वापस मिल जाते हैं. That's how the reaction is complete. So yes, sir, is this all clear? ये clear है पिछला? Remember, ये बहुत important है. ठीक है, this is like you pretty much get a lot of questions on this. Sara clear है? Sara, is this clear? Alicia?
Yes, sir.
अच्छा अब अच्छा, अब जो अगला पार्ट है ना वो ये कि again it's related to this. ठीक है, so it's all related to this. So we're going to study the same thing, which is electrophilic substitution, but now we're going to talk about we're going to talk about benzene derivative compounds. So there would be a lot of compounds that look like benzene. I mean, the kind of and they behave like benzene because they've got a benzene ring in them. But they're not just benzene. They're more than benzene. Okay, so electrophilic substitution of benzene derivatives. अच्छा, इसमें ना there are two types of so there are two types of benzene derivatives. One of them, the first type, that's known as 2,4 directing groups. So the first one is अच्छा 2,4 or 6 भी कह देते हैं 2,4,6. So we're going to talk about electrophilic substitution of these groups. What's a 2,4 directing group? We need to first figure out what it is. So 2,4 directing group, इसके वैसे वो data booklet में भी है, so we'll learn the exact. Okay, where's the data booklet? Just a second. Okay, अब data booklet नहीं है, so you have to remember this. अच्छा, 2,4 is this thing. ठीक है, so ठीक है, I'll copy this as a reference. इधर post कर देते हैं. And I'll explain what this is.
सर 6 क्या है?
अभी मैंने बताया नहीं, अभी मैं बताता हूँ. ठीक है, मैं एक्सप्लेन करता हूँ. अच्छा, ये ग्रुप्स हैं 2,4,6, वो एक्सप्लेन करता हूँ. I'll explain. If you look at the image, it's 2, 3, and 4. Those are positions. So what's a 2,4,6 directing group? You've got NH2OH, alkyl chains, chlorine, amides as well, right? So they're all 2,4,6 directing groups. Now, what happens is, किसी एक को ले लेते हैं. Let's start with the first one. ठीक है, number 1. We're going to talk about electrophilic substitution of arenes. ठीक है, of arenes. So the first question is what is an arene? So an arene is benzene. So arene is basically benzene plus an alkyl chain. So it's a benzene plus an alkyl chain. That's what it is. Like if I draw this, it's going to look like this. It's going to be ये सब होगा फिर this. So it's going to have, and there's going to be as a plus, there's going to be CH2 and let's say a CH3. So what it basically is a carbon chain. उसको highlight कर लेते हैं. अच्छा ये है बस. So it's an alkyl chain that's attached to any alkyl chain that's an arene. No matter how small, big or small, it's still, you can have multiple alkyl chains as well. So for example, there's this benzene, and there might be two C alkyl chains. For example, there might be a methyl, which is on one of the carbon atoms. And there could be another methyl that could be on. So you could have CH3 on one and a CH3 on the other one as well. Joby, as long as you got alkyl chains attached to it. Okay, that's what an arene is. Achha, arenes, Joanna, that's what do arenes do? As a first thing, you just need to know basic naming. This is known as ethyl benzene, the first one, because you've got a carbon chain that's attached to a. So that is attached to a benzene. The second one, you got two methyls, so it's a dimethyl. हाँ जी.
सर जिस तरह से वो पिछले वाले में कहते कि पोजीशन मेंशन करते थे, इसमें तो उस तरह से नहीं कर सकते ना.
पोजीशन क्या?
सर जो मतलब पोजीशन लाइक मेंशन कर देते ना, अल्केन्स और अल्कीन्स लाइक जो अल्काइल की ब्रांचेस थी ना, इसमें तो इस तरह से नहीं कर सकते ना.
इसमें करना है, सेकंड वाले में करना है 1 3. ठीक है, मैं बेसिक बता रहा हूँ कि यू स्टार्ट क्लोजेस्ट, उधर से काउंट करो, यू विल गेट बिगर नंबर्स, सो यू विल काउंट फ्रॉम द साइड दैट गिव्स यू स्मॉलर नंबर्स. सो दिस इज 1 3 डाइमीथाइल बेंजीन. ठीक है, उसके अंदर यू डोंट हैव टू राइट पोजीशन बिकॉज इट इज अटैच्ड ऑन नंबर 1. मतलब जिस पे भी अटैच्ड है दैट्स नंबर 1. इज दैट क्लियर? तो बेसिक नेमिंग. ठीक है, बिकॉज in benzene and derivative compounds usually don't have systematic naming. ठीक है, तो systematic naming बस इतनी systematic naming होती है कि अच्छा ठीक है, this is at 1, so this one is at 3, so it's there's a methyl at 1, there's a methyl at 3. So you just count from the side that gives a smaller number. So you're not going to count from the other side because you're going to get bigger numbers. अच्छा, अब question ये कि well, what's a 246 directing group? Now these are all 2 4, ये लिखा हुआ है, these are all 2 4 6 directing groups. They direct the incoming group to positions 2 and 4. तो पहले इसका मतलब समझ लेते हैं. ठीक है, so 2 4 6 directing groups or 2 4 directing groups are electron donating groups. So directing groups so they are electron donating groups. What that means is that when you have a benzene attached to it, ठीक है, एक benzene उठा लेते हैं, when you have that attached to it, so इसी को उठा लेते हैं. Just when I have a benzene, so this is वो NO2 में हटा देता हूँ. Let's put a carbon chain next to it. So instead of this thing, I've got a CH2 and a CH, let's say a big alkyl chain, propyl benzene. let's say I've got this propyl benzene. What's going to happen in this case is कि, so what's going to happen in this case is that alkyl chains have an electron donating effect, a very slight electron donating effect. Whenever you attach an alkyl chain next to anything, the electrons are, so whenever you attach an alkyl chain next to any group, वो उसमें भी पढ़ा था carbocations के अंदर, we studied that they have an electron donating effect, a very slight, not a very large one, because they've got a lot of electrons. कि आपके पास, if you have CH2 and CH3, that's a total of how many electrons? That's 6 plus 2, 8, 8 and 9 over here. So that's 16 plus 9, 25. So that's a total of 25 electrons. So slight, or slight word मैं use करूँ, not a very strong electron donating effect, a very slight. क्योंकि अभी आगे जाके पढ़ेंगे comparison में, this one is going to be slight. I said now what that will do is your benzene electron cloud, which was kind of equally distributed, the electrons equally distributed, are no longer going to be equally distributed. The benzene is no longer going to be symmetric. It's not going to be evenly, हर चीज evenly distributed नहीं होगी in this case now. So what is going to happen is कि on one side the electron density is going to be a lot higher. मतलब ये वाली जो side है ना, इधर आपकी electron density जो है that will increase in size. ठीक है, ये नहीं पता हुआ, ये मैं draw कर लेता हूँ. So the electron density is going to significantly increase. So एक side पे electron density will become significantly higher. वो clear है कि because it's attached to a lot of electrons, those electrons are going to overlap with this one and they'll increase the negative charge on this side. And all the other electrons, because of the negative charge that's building up on the right side, what is also going to happen is कि आपके जो all the rest of the electrons are going to be repelled. They're going to be repelled and they will all accumulate on the extreme left side. They'll all get pushed to the extreme left. So electron density कहाँ पे ज़्यादा हो जाएगी? It will become higher on the extreme left as well. तो बस ये idea है, ठीक है? What is going on is, हाँ जी,
सर ये point repeat कर दूं.
वो था ना कि carbon chain has an electron donating effect, ठीक है? There are 26 electrons. So when the carbon chain gets attached to it, तो यहाँ पे the number of electrons of the negative charge and its charge density increases. It becomes higher. ये clear है?
सर वही वाला repeat करने के charge density ज्यादा क्यों?
क्योंकि यहाँ पे electrons है ना, मतलब इसके carbon chain has an electron, ये अपने electrons थोड़ा सा negative charge spills over onto the benzene. So what happens? यहाँ पे number of electrons, yeah, not the number of electrons, but the negative charge density that increases a little bit. Is that clear?
Yes, sir.
और फिर वो क्योंकि ये side it's got more electrons or slightly more negative charge, ठीक है? So all the other electrons they get repelled because of that, and they accumulate on the extreme left. ठीक है, clear है?
Yes, sir.
अच्छा, so what happens is because of this, electron density is higher at position number 2. It's higher at position number 4. और इसको ना position number 6 कहते हैं, this one. But if you count from one side, your electron density is now going to be significantly higher at these positions. ठीक है, 2, 4 and 2, 4 and 6. And the electron density is going to be lower. अगर मैं यहाँ से count करूँ, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. अच्छा, the reason you don't write 6 is that जो आपका 6 है ना, that's 2 and 6 are kind of the same position. हाँ जी.
सर जो electron density है at position number 4 सर वो सारे repel हुए होते हैं वहाँ पे?
हाँ, क्योंकि यहाँ पे कार्बन चेन है तो वो उसके इलेक्ट्रॉन इधर जमा हो गए, इसके साथ मिल गए हैं, तो इलेक्ट्रॉन डेंसिटी इस साइड पे हायर है। तो अब इस साइड पे अगर इलेक्ट्रॉन डेंसिटी हायर है तो बाकी इलेक्ट्रॉन्स जो रह गए ना वो दे ऑल गेट रिपेल्ड ऑन द अदर साइड। ठीक है।
और सर ये पोजीशन नंबर 6।
पोजीशन नंबर 6 ये 1 है, मतलब जिस पे प्रोपाइल अटैच्ड है। दिस इज नंबर 2, दिस इज 3, दिस इज 4, दिस इज 5, दिस इज 6।
हाँ सर, वो भी लाइक शेडेड है तो इसलिए पूछा था 6।
हाँ, तो टू पोजीशंस 2, 4 एंड 6 के ऊपर ना इलेक्ट्रॉन डेंसिटीज आए।
ओके सर।
वो मैं कहता 6 को ब्रैकेट में यू डोंट राइट 6 इज के 2 and 6 are kind of the same position, but 2 and 6 are exactly the same position. Is that clear?
यस सर।
तो ये सारों को क्लियर है कि दिस इज व्हाट इज गोइंग टू हैपन, दिस इज व्हाट इज मेंट बाय 246 डायरेक्टिंग ग्रुप्स, that they are electron donating groups. And what happens is because of these groups ये चीज होती है कि charge density becomes higher at positions number, so you've got a higher charge density. अच्छा, at positions 2, 4, and you can include 6 as well. So you've got a higher charge density at positions 2, 4, and 6. And also because of that, electrophiles किसके साथ, अगर NO2+1 होगा तो किसके साथ attract होगा? It's going to get attracted to, it's not going to get attracted to positions 3 and 5. It's going to be attracted to positions 2, 4, and 6. So ये important चीज है कि you'll have major and minor products. The more likely product is going to be a 2, 4, 6 product. The electrophiles, will be strongly,
सर।
हाँ जी,
सर इसमें भी मार्कोवनिकॉफ रूल यूज होगा?
नहीं मार्कोवनी का रूल तो डिस्कस नहीं किया, वो तो कार्बोकैटायंस के लिए था।
नहीं सर, आपने मेंशन किया कि मेजर और माइनर प्रोडक्ट्स।
नहीं, लेकिन मार्कोवनी का रूल तो नहीं ना। ठीक है, मतलब मार्कोवनी का रूल की तो बात नहीं आई इसमें ना। इसमें तो वो है कि the simple thing is that the electrophiles are going to be attracted to positions 2, 4, and 6. Why? Because वहां पे charge density is higher. ठीक है, clear? तो ये आपका ना, this remember this is all your uh, this is what is meant by 246. अच्छा, फिर इसमें we'll discuss के we'll talk about वो जो बेंजीन के रिएक्शंस किए थे ना हमने, I'm going to talk about the same reactions. किधर लिखे थे हमने, लाइक अपने स्टार्ट में लिखे थे। अच्छा, these reactions. So I'm just going to rewrite these reactions, except के अब I'll have an arene, not a benzene. So the same reactions now, as the same reactions, but now for as the same reactions now for arene. So what if you did not have a benzene, instead you had an arene? Arene में क्या होगा कि instead of this normal benzene, what you'll have is कि इसके साथ there's going to be a carbon chain that's going to be attached. तो you might have बस एक CH3 लगा देते हैं। You've got a CH3 now, ठीक है, और बाकियों का भी यही है, तो इनको डिलीट कर देते हैं। So instead of a benzene, I've got this. And I've got this. Similarly, your products. Now, what are your products going to be? ठीक है, so products वही होंगे, सब कुछ वही होगा। except for one difference. One is that you already have ये इन सारों के साथ ना, बल्कि इन सारी जगहों पे भी ना ये उठा के कॉपी पेस्ट कर लेते हैं. अच्छा, so the product is going to be similar, except you're going to get two different products. ठीक है, there's going to be two different products. One is कि मैंने क्या कहा था कि it's the electrophile is going to be attracted to positions 2, 4, and 6. So it's not going to get attached to the bromine. It's not going to get attached to any carbon atom. It's going to be attached to either position number 2, or it's going to be attached to position number or to position number 4. तो या तो वो इधर होगा और या फिर इसको थोड़ा उधर कर ले. अच्छा, तो या तो bromine is going to get attached to position number 2, or it's going to get attached to position number 4. Same over here, chlorine, if it's either going to get attached to position number 2, or it's going to get attached to position number 4. And this one as well, NO2 is going to get attached to position number 2 or position number 4. वहां पे electron density is higher. So these are the positions where Br will be attached. ये वो positions are where Cl gets attached. And बाकी सब कुछ वही है. It's everything is the same, except now because of the presence of the alkyl chain, the electron density is not exactly the same on the entire benzene. So the electrophile is now a bit more picky, a bit more choosy about the positions that at which it's going to get attracted to. Or byproduct भी वही होगा. It's going to be HCl, sorry, HBr over here, the first one. और यहाँ पे it's going to be, अच्छा यहाँ पे it's going to be HCl. ठीक है, बस ये है और कुछ भी नहीं है. इसके ऊपर लिख भी देता हूँ. It's अच्छा, I'm going to write the names as well, ताकि थोड़ा बहुत ना नेमिंग का भी आइडिया हो जाए. Although you just need to know basic structure of naming. That's
सर
हाँ.
सर वैसे इसके अंदर 6 नहीं आता होगा ना, 6 पर अटैचमेंट.
नहीं, वो 6 और 2 एक ही चीज है ना. मतलब मैं अगर 6 पे कर भी दूं ना अटैच,
अच्छा, तो मतलब दूसरी साइड से भी वही 2 कंसीडर कर सकते हैं.
तो उसको उसको 2 ही कहोगे आप, क्योंकि स्मॉलर नंबर लेना है ना. ठीक है. हाँ, वो यू कैन हैव 6 अगर वो 2 पे भी हो और यहाँ पे भी हो. देन वन ऑफ देम इज गोइंग टू बी 2, द अदर वन इज गोइंग टू बी 6. उस केस में 6 हो सकता है, वरना वो दूसरी साइड से करोगे काउंट तो उधर से स्टिल गोइंग टू बी 2. अच्छा, दिस वन इज अच्छा अल्काइल चेन्स की ना थोड़ी सी प्रेजेंस हायर होती है, तो यू गोना कॉल इट मिथाइल बेंजीन. दिस इज 2 ब्रोमो. मिथाइल जो है ना 1 पे होगा और ये दिस इज गोना बी एट 2. सो इट्स गोना बी 2 ब्रोमो मिथाइल. मिथाइल बेंजीन. और फिर दिस other one is going to be, this is at 1, this one will be at 2, 3, 4. So this is going to be 4 methyl, sorry, 4 bromo methyl benzene. ठीक है, क्लियर है ये. और वही चीज द नेक्स्ट वन. ठीक है, इट्स द सेम. अच्छा, इधर इधर दिस वन, द नेक्स्ट वन, इसका मैं बता देता हूँ कि दिस वन ओवर हियर, नाइट्रो की प्रेसिडेंस जो है ना वो दैट्स हायर. So this is called a nitrobenzene molecule with, so this is 2 methyl, this is 4 methyl nitrobenzene. And this one is going to be 4 nitro. तो बेंजीन के साथ ना there's a nitro and there's a methyl, ठीक है? Both of them attached.
सर
हाँ जी.
सर इसके अंदर वो जो आप मैकेनिज्म लाइक एरोज ड्रॉ करते थे जो इलेक्ट्रोफिलिक सब्स्टिट्यूशन की होती है सर
वो तो
वो
वही
यहाँ
है.
पे भी ड्रॉ करेंगे ना आप लोग? अच्छा अच्छा.
हाँ वो तो exactly वही होगा. बस ये होगा कि difference will be कि if I go back तो same mechanism होगा कि there's going to be a let's say methyl group. हाँ बस ये NO2 जाके ना attach it to the right carbon atom. बस ये इसका ख्याल रखना है. It's either going to be at 2 or it's either going to be at 4. Is that clear?
यस सर.
अच्छा एक सेकंड में मैं ये नहीं चलो ठीक है बस मैंने वही देखा था कि नाइट्रो 1 पे होता है ठीक है उसकी प्रेजेंस इज हाई. अच्छा बट एनीवेज दैट्स इट. अच्छा तो now this is further I mean still electrophilic substitution it's the same thing. तो ये सारा क्लियर है सीम उमर सिद्रा एंड अलीशा इज दिस ऑल क्लियर?
यस सर.
सर नाइट्रो 2 पे नहीं होगा?
नहीं नहीं नाइट्रो की ना वो प्रेसिडेंस हायर होती है ना तो वो जस्ट 1 नाइट्रो होगा. नाइट्रो आई मीन यू गिव द वो उसमें प्रेसिडेंस का जो ऑर्डर होता है ना उसमें होता है कि नाइट्रो जो है ना दैट्स मोर इम्पोर्टेंट. अल्काइल चेन की एक्चुअली कोई इंपॉर्टेंस नहीं होती. सो यू ऑलवेज गिव अ बिगर नंबर टू अल्काइल चेन. क्लियर है बात? मतलब कोई भी ग्रुप अटैच्ड
सर
होगा ना.
ऊपर
हाँ
सर ऊपर 246 जो डायरेक्टिंग ग्रुप था उसके अंदर जो एल्काइल चेन थी वो स्लाइटली डोनेट कर रही थी
हाँ
इलेक्ट्रॉन.
हाँ.
ओके सर.
असल में आपने थोड़ा सा चेंज लिखा है ना वो लास्ट वाला नाइट्रो का तो इसलिए मैं पूछ रहा था.
ये क्या लिखा हुआ है? अच्छा वो मैंने गलत लिखा हुआ है आखिरी. वो 4 मीथाइल नाइट्रोबेंजीन है. दिस वन इज 4 मीथाइल नाइट्रोबेंजीन वो गलत था. ठीक है नाइट्रो नंबर 1 पे और फिर 4 मीथाइल 4 पे. ठीक है मतलब वो ऑर्गेनिक केमिस्ट्री में उस नेमिंग भी था कि यू गिव द स्मॉलर नंबर टू द मोस्ट इंपॉर्टेंट बट इफ यू हैव एनी फंक्शनल ग्रुप यू गिव इट अ स्मॉलर नंबर. अल्काइल चेन्स की आप परवाह नहीं करते उनको जो मर्जी नंबर मिले. ठीक है. अच्छा एनीवे सो दिस इज जस्ट वन वी डिड एरीन्स. एरीन्स की इलेक्ट्रोफिलिक सब्स्टिट्यूशन जो है ना वो खत्म हो गया. अब इस तरह थोड़ी और कंपाउंड्स भी उनकी वी हैव टू डू इलेक्ट्रोफिलिक सब्स्टिट्यूशन ऑफ those compounds as well. So the first one that we have done is we're done with electrophilic substitution of arenes. ठीक है इसको ये पहली चीज हमने कर ली है. अभी हमने we have to do a few more. ठीक है we're done with alkyl. We're going to talk about amines and alcohols as well. ठीक है and their electrophilic substitution as well. तो फिर नेक्स्ट क्लास में करते हैं. ठीक है उनकी वो भी 246 डायरेक्टिंग है सेम लॉजिक बस उसकी द कंडीशंस विल चेंज इन दैट केस. वो फिर कल करते हैं.
सर
चल
इसके
ठीक
बाद
है.
क्या होगा?
हाँ जी
इसके बाद कौन सा होगा?
अभी इलेक्ट्रोफिलिक सब्स्टिट्यूशन ही करेंगे लेकिन ये वाली करेंगे फिनॉल्स की और ये अल्कोहल्स OH आता है NH2 दैट्स नोन एज फिनाइलमाइन.
ओके
बेंजीन के साथ OH होगा ना यहाँ पे तो दैट इज गोइंग टू बी कॉल्ड अ फिनॉल. बेंजीन के साथ इफ देयर इज अ एमाइन दैट्स नोन एज फिनाइलमाइन. ठीक है
ओके सर.
बस इसके एंड पे खत्म हो जाएगा. प्रॉब्ली अभी इस मंथ के अंदर खत्म हो जाना चाहिए. ओके एवरीवन.